Hello students, today we are going to learn about surface areas and volumes of various figures. Just a quick recapitulation of the figures that we have already studied. We know how to calculate the surface area and volume of cone, sphere, cylinder and cuboid. This is what we have already learned in Standard 9. Today, we will understand how to calculate the surface area of a combination of solids. For example, a cylinder plus a cone. You can see a castle. So how will you take out the surface area of the entire castle, which is cylindrical and conical in shape? Again, to calculate the surface area of tent, which is a combination of cylinder and cone, an ice cream cone, which is a combination of a cone plus a hemisphere, a capsule, which is a combination of a cylinder and two hemispheres, a tanjore doll, which is a combination of a cone plus a hemisphere. You can see a little breakup of these combinations. A capsule, which is equal to a cylinder plus two hemispheres, an ice cream cone, which is equal to a cone plus a hemisphere. So what is a total surface area in relation to curved surface area? Please understand that a curved surface area is the surface area which is lateral. For example, in the given figure, we are able to see only the curved surfaces of two hemispheres and the curved surface of the cylinder. So the total surface area of the new solid is the sum of the curved surface areas of each of the individual parts. Therefore, total surface area of this solid will be equal to curved surface area of one hemisphere plus curved surface area of the cylinder plus the curved surface area of the other hemisphere. Let us understand this through an example. Two cubes, each of volume 64 centimeter cube, are joined end to end. Find the surface area of the resulting cuboid. As you can see in the figure, there are two cubes which has a volume of 64 centimeter cube. Now because the volume has been given as 64 centimeter cube, so you know that the volume of the cube is equal to A cube. So A cube is equal to 64. So to take out A, you will have to take out the cube root of 64, which is equal to 4. So 4 is the side of the cube. So once you come to know that 4 is the side of the cube, you can take out all the sides of the cuboid. The length and the breadth will be 4 centimeter each and the height will be 8 centimeter. So you can see the explanation done on the same lines over here, and you are getting the side of the cube as 4 centimeter. So now we will take out the surface area of the cuboid. The formula is 2 into LB plus BH plus LH. So putting the values in this formula we can get the surface area of the cuboid as 160 centimeters square. A second example wherein a toy is in the form of a cone of radius 3.5 centimeter mounted on a hemisphere of same radius. The total height of the toy is 15.5 centimeter. So you need to find the total surface area of the toy. So as you can see, it's a cone surmounted on a hemisphere. The radius of the cone is given. So which means the radius of this hemisphere is also 3.5. The height of the toy is 15.5. The total height has been given 15.5. So we subtract the radius of this hemisphere, this part of it, which is the radius, we subtract. So we get height of the cone, which is equal to 15.3 minus 3.5 equals to 12 centimeter. Now we use the formula. Slant height of the cone equals to h square root over h square plus r square. Using this Pythagoras theorem, we can find out what is the slant height. Hence, we can find out the curved surface area of the cone using the formula pi rl. Once we know the curved surface area of the cone, the curved surface area of the hemisphere is 2 pi r square. So using this formula, we get 77 centimeters square. So the total surface area of the toy is curved surface area of the cone plus the curved surface area of the hemisphere. Adding both, you can find the total surface area of the toy, which is 214.5 centimeters square. Next example, a cubical block of side 7 centimeter is surmounted by a hemisphere. What is the greatest diameter of the hemisphere? Find the surface area of the solid. So you need to find the complete surface area of the solid. It is given that the side of the cube is 7 centimeter. So the hemisphere which is on top, which will have half of it as radius. So radius of the hemisphere is 7 by 2. Now using the logic of calculating the total surface area of the solid, which is equal to surface area of the cubical block plus the curved surface area of hemisphere minus the area of the base of hemisphere. So I hope this part is very clear, because we need to take out the total surface area of the solid. So this part which is the base, you can see this part which is the base, this part will be coming twice if you add surface area of the cubical block plus the curved surface area of the hemisphere. So you will be getting this area twice. Since you're going to get this area twice, you need to subtract the area of the base of the hemisphere. So this is going to be the area of the base of the hemisphere, which is going to be a circle. So area of the circle is pi r square. So we subtract pi r square from the sum of surface area of cubical block plus surface area of the hemisphere. So use this formula, substitute the values, you'll be able to get the surface area of the solid, which is 332.5 centimeters square. The next question on a capsule. A medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its ends. The length of the entire capsule is 14 millimeter and the diameter of the capsule is 5 millimeter. Find its surface area. So as you can see in the figure, 14 millimeter is the length of the capsule and the diameter of the capsule is 5 millimeter. So Capsule will be having the shape of the cylinder plus two hemispheres in its end. So you can see this is one hemisphere, this is another hemisphere, and this part is the cylindrical part in the center. So 5 millimeter is the diameter, so 5 by 2 will be the radius of this hemisphere. And similarly, if 14 millimeter is the length of the capsule, you will subtract the radius of from both the sides to get this length of the cylinder. So you can see this calculation done over here. So 2.5 is the radius, you can see. This is the radius, this is the radius 2.5, which we subtract from 14. So from 14 when we subtract, you get 9 millimeter as the length of the cylinder. So surface area of the hemisphere, you use 2 pi r square. Using this formula, you get 275 by 7 millimeter square. And surface area of the cylinder is 2 pi rh. So you get 990 by 7 millimeter square. So to get the surface area of the medicine capsule, you need to multiply the hemisphere's surface area twice and add to the area of the cylinder. So you get 220 millimeter square. Just a quick recapitulation of the formulas that are there. So if it's a curved surface area, so the formula is 2h into L plus B, and the total surface area will be 2 into LB plus BH plus HL. And for cube, it's going to be 4a square, and the total surface area would be 6a square. A right circular cylinder will have 2 pi rh as the curved surface area, and total surface area will be 2 pi r within bracket r plus h. For right circular cone, pi rl is the curved surface area, and 2 pi r within bracket r plus l is the total surface area. For a sphere, you don't have a curved surface area, just the total surface area is 4 pi r square. And a hemisphere will have 2 pi r square as the curved surface area, and total surface area would be 3 pi r square. Thanks. That's all for today.